You know, in trigonometry, sometimes the ideas that seem really tricky at first turn out to be surprisingly simple once you see them the right way. And today we're going to tackle one of those concepts, coterminal angles. So let's break it down.
Okay, let's kick things off with a little puzzle. What on earth could a simple 60-degree turn have in common with a big 420-degree spin? They sound worlds apart, right? Well, the answer to this question is actually the key to this whole thing. And the secret, believe it or not, starts with something we've all done before, just spinning in circles.
I want you to picture this. You're standing up, facing forward. Now, imagine you spin around one full time. That's 360 degrees. Where do you end up? Right back where you started, facing the same direction. What if you do two full spins, 720 degrees? Same deal. Your final position is exactly the same. And that right there, that's the perfect picture of what we're talking about in math. Angles that start in the same position and end in the same position, no matter how many extra laps they did along the way, have a special name. We call them coterminal angles. And you know what? The name itself basically gives the whole game away. Co means shared or together, and terminal means ending. So coterminal literally just means shared ending. It's that simple. They land on the exact same line. Okay, so we've got the concept down. It makes sense, but how do we actually use this? How do we turn it into a tool for solving problems? Well, that's where the formula comes in. Honestly, the rule could not be easier. If you want to find an angle that's coterminal with another one, all you have to do is add or subtract a full circle, 360 degrees. And the cool part? You can do it over and over and over again, generating an infinite family of angles that all land in the same spot. So here's what that looks like in math terms. Our new coterminal angle equals the original angle, that's theta, plus or minus 360 times n. Now what's n? It's just how many full circles you want to add or subtract. If you want to add 2 rotations, n is 2. If you want to subtract 5 rotations, n is 5. It can be any whole number you want. All right, enough with the theory, right? Let's make this real. It's time to get our hands dirty and actually put this formula to work finding some angles. Let's take a simple angle, say 110 degrees. If we want a positive coterminal angle, we just add 360. Boom, 470 degrees. If we want a negative one, we subtract 360. That gives us negative 250 degrees. So 470, negative 250, and our original 110 all point in the exact same direction. Okay, that was pretty straightforward. But you might be thinking, so what? Why do I need to do this? Well, imagine you get a problem with a massive angle, something like 1250 degrees. Trying to even picture that is a real headache. This is where coterminal angles become your best friend. The most obvious way to tackle this is to just start unwinding it. We take 1250 and subtract a full circle, 360. We get 890. Still way too big. Let's do it again. Now we're at 530. Still bigger than a circle, one more time, and we land at 170 degrees. Now that's a nice, simple angle we can actually work with. Now look, that totally works, but it's a little slow, right? Let me show you a shortcut. Just take your big number, 1250, and divide it by 360. Your calculator will say something like 3.47. That whole number, the 3, that tells you there are 3 full rotations hiding in there. So you can just subtract 3 times 360, which is 1080, all in one go. You get the same answer, 170 degrees, but way faster. So this ability to simplify angles is super powerful. But it also sets up a really common trap that a lot of people fall into. So we need to clear this up right now. It is so easy to fall into this trap. You see that a 60-degree angle and a 420-degree angle end up in the same spot, and you think, aha, they're the exact same thing. But they're not. The final position is the same, but the journey to get there, the actual amount of spinning or work done, is completely different. And if you're still not sure, this peanut butter jar analogy is going to make it crystal clear. Imagine twisting the lid. A small 60-degree turn might just loosen it. But a 420-degree twist? Well, that's one full rotation plus another 60 degrees. That lid isn't just loose anymore. It's probably popped off and flown across the kitchen. Same ending position, totally different outcome. Okay, so this difference between where you end up and how you got there isn't just for math class or kitchen jars. It actually shows up in some really cool, high-energy places. Believe it or not, the entire world of action sports is basically built on coterminal angles. When a snowboarder pulls off a big spin, they start facing downhill. And to land the trick cleanly, they have to end up facing downhill too. Just look at this. A
A 360 is one full rotation. A 720 is two full rotations. A 1080, that's three full rotations. From a math perspective, they all start and end in the same position. They're all coterminal with 0 degrees. The only difference is the amount of rotational work they did in the air. And that's what gets you the gold medal.
Okay, so let's bring this all home. Why does any of this actually matter for you? First, as we saw, it lets you take a crazy angle, like 5,000 degrees, and boil it down to something simple. But second, and this is absolutely huge for trigonometry, coterminal angles have the exact same sine, cosine, and tangent values. That means finding the sine of 5,000 degrees becomes the much easier problem of finding the sine of 320 degrees. This is a skill you are going to use all the time.
So I want to leave you with this question. We just took a concept that feels infinite, angles that spin around and around forever, and we found a simple rule to make it all make sense. It just makes you wonder, what other parts of math that seem super complex right now are just one new perspective away from becoming simple? Thanks for watching.